that people are complaining the process of getting the APIs defining the UEFI ACPS spec being too long, right? So there's another alternative approach that's being discussed, actually. I hope somebody actually proposed a session here, but I didn't, which is about the code-first approach. So traditionally, when you submit a change, there's a blackout period where the material becomes UEFI forum confidential, right? And then only after the spec gets published where you can actually define the solution, open source implementations and such. But now the alternative approach is you can just go ahead and do the coding, do your own change request in the open. So we're setting that up in the Tiano Core open source community. And you define the APIs, you work with the community. When it is mature enough, you have the code to implement to your specification. Then you can submit to the forum. And at the time, hopefully, all the people who are having a stake in this interface already review your code, already review your change request, and it's just a rubber stamp in a forum. So I think that actually will help quite a bit for the open source community. So just a comment, because I have heard a couple of comments today related to the slowness of a spec. And believe me, that's not the worst. If you go to PCI, it's 14-day review after the workgroup approved an ECR, and another 60-day for the IP review. So it's probably a long, long time before you can see any of the specs. But anyways, that's not my topic today. So I'm here to talk about the server base manageability guide for these ARM servers that we call the SBSA Compliant. And again, I think for this session, actually, Suprise is the one who proposed the abstract and the content. I'm only here to present because he's not. So I'm going to talk about the rationale, history, introduction, and some of the prototype work, and a roadmap and plan for this. So the SBMG is really here to address an issue that, like I mentioned earlier today, for ARM ecosystem, we support a diverse variety of systems, right? So with the diversity comes a complication as well, because here I'm talking about the BMC. So because each of the SoC vendors, ARM doesn't, before this SBMG effort, ARM didn't have a guidance for how you should design your BMC support for your system. And so in that case, the silicon providers work with the BMC providers, and they come up with solutions individually. And the problem of that is when you install these servers into the data center, right, each of the vendors will present you with something different. It's all BMC, but it's a different implementation. There's no common, not necessarily a common set of experience. You may see a few common commands, but we don't know, right? Because everybody does their own definitions and design. So the intent of the SBMG is for ARM to work with our ecosystem partners to standardize a minimum set of server manageability capability so that people can still do the customizations on top of it, but the users can expect at least a common set of interfaces. So one of the issues we also run into is that in this space, there are a few things that are not quite standard. If you look at the x86 processors, on the Intel side, you would see things like the eSPI, low pin count interfaces, right, from the BMC to the CPU or the chipset. on AMD, actually on Intel, there is also this PECI interface. On AMD, there is an equivalent of a PECI interface as well. So we don't have any of that. And in fact, many of these specifications from, for eSPI, low pin count, these are Intel specifications. Even though the implementation on the client side on BMC are enabled, BMC vendors all implement those interfaces. But we're not sure, at least from the ARM perspective, we're not sure if we can implement eSPI or low pin count interfaces in the host CPU. So it will have to be each of the silicon providers somehow working out a deal with Intel or somebody to implement that interface into the host CPU. So we don't have that capability. And so the stuff that we're looking at, the interfaces that we're looking at are standard interfaces, right? I2C, maybe later on I3C, PCI, USB, that kind of interfaces. So we want to use that. But also, because I think I2C, I don't know about you, but I think the I2C is getting to be too slow, right? Especially if you're talking about sending firmware update packages across, I2C is really, it can take days maybe to get things done. So maybe that would be something for I3C to come to support. But for us to define this specification, the way we were thinking about doing was to not define or require a physical media. Physical media may change over time, from I2C to I3C, for example. But we want to define some baseline that are common across the board, and we don't have to change these drivers all the time. So the thinking that we have is we will focus our efforts on a few things. So Redfish, I think you have heard about it, everyone, right? And so on the interfaces to the customers, to the users, certainly we want to support Redfish. But IPMI is here to stay for a while. I guess the transition is not quite done yet. So we're going to support IPMI interface commands as well. But in a lot of the communications between the SoC and BMC to some of the sensors and all that, the attempt we are doing is to try to use the abstraction definition. So we want to use MCTP, and then we want to use PLDM on top of MTCP to send packets around. So the nice thing about this is that if you have the MCTP definition there are bindings of MCTP over a lot of physical media, I2C, SM bus, PCI, VDM, and such, right? So if the physical media changes, that's fine. We could still support the same protocol and the same PLDM for different purposes. PLDM could be used for firmware updates. It could be used for sending sensor information around. And also, DMTF is defining this JSON-enabled data schema, right? So we can support that as well. So that's kind of the overall thinking that we have. So the history is, in the morning sessions, we started off trying to standardize on the host side of this, the hardware, minimum hardware, and then we tried to define the required interfaces for the firmware, and I talked about the test suites, right, for the compliance checking for those. But now we are kind of entering to the space where the server manageability needs to have the standardization so that the customers, the users, can expect at least a common set of interfaces that they will get. And so together with these other specifications, we can have a standard-based approach to build ARM servers. And again, the SBMG, the specification is developed within that same ARM Server Advisory Committee community that I talked about earlier also. And there's a mailing list and data issue tracking database. So we want to help guide the ARM server designers to provide common manageability. And to accelerate the development of these specifications, we started off with 3 sub-teams, but now I think 2 of them are combined. The platform monitoring and control team is combined with the RAS team because I think they are kind of addressing the similar kind of areas where the physical media, the interfaces are being talked about. It's basically the same kind of people who join those teams. And then we also have the remote debug. Everybody is interested in how you remote debug the server. So we want to put down some kind of baseline feature sets. And in terms of the RAS, we are defining the error record format. And we are leveraging this thing called CIPA, which is in the UEFI specification for common platform error records. And then we are also defining the SOC to BMC manageability interfaces for the RAS errors. This is because a lot of the interfaces are defined from the OS firmware side to the host SOC, but the interfaces to BMC were not quite standardized, at least on the ARM side of definitions. And we want to also define a fault notification signal, define interfaces and mechanism for injection of the RAS errors. I think it's kind of a common thing here now, right? If you think about the last session. And we also want to do the monitoring and control. We want to define interfaces needed for the BMC and the SOC to communicate for the platform monitoring. And here, because this is actually touching the platform side, and we are targeting the hyperscalers, the cloud vendors. So it makes a lot of sense to us to leverage as much as possible the specifications that are defined by OCP, right? So we want to work with you, work with the community to do that. And we want to analyze the use cases for standardizing many of these communications, BMC to SOC, BMC existing SOC to do the power actions, and BMC to monitor the health of SOC and the boot progress, watchdog usages, all these things. And so the status of this is that as of this month, so the RAS and monitoring team have been merged. And then the team is entrusted to define the interfaces for the communications between the BMC and the satellite controller, which is actually associated with the SOC. And also, for the remote debug side, we are in the process of trying to figure out a way to gain visibility of the hardware and software behavior of the SoC using a debugger that is not directly connected to the server SoC. ARM coming from the embedded and the mobile space typically have the debugger that connects to the SoC side directly, right? But on the server side, that's not practical. And if you deploy hundreds and thousands of servers, then you have to have a way to do the remote debug. And so we're defining for the communication between the debugger and the BMC. And then we also define physical interfaces between the BMC and SoC, defining the protocol for BMC and SoC. And then we also trying to figure out a mechanism to ensure that only the suitable debuggers can have access to SoC. Of course, there's also security concerns as well. And then we are also doing a prototype. So we are working on OpenBMC. OpenBMC, I think everybody is aware, that's a Linux Foundation project now, and it's a highly extensible framework for BMC. And so OpenBMC to us now is kind of a reference implementation for what we want to specify in this SBMG guide. And so ARM and the silicon providers are participating in the OpenBMC development. So we will target an implementation of OpenBMC that can verify our specification. And by the way, we also joined the OpenBMC Technical Steering Committee. It used to be 5 members who formed the OpenBMC effort, and now ARM is the 6 TSC members. Oops, sorry. Okay, so in terms of a remote debug, we are also proposing a design to integrate the OpenOCD with the OpenBMC stack. OpenOCD, if you're not familiar, is an open source on-chip debugging solution for JTAG connected processors. So it is enabling the software level, source level debugging with the GNU GDB. So it can also integrate with the GDB-aware IDE, such as the Eclipse. So we have completed the first phase of the implementation, which included the demonstration of GDB connection on port 3333 to OpenOCD debug server daemon running on OpenBMC. So that work has been done. And then the next phase of the implementation is to utilize a wrapper which can add a JTAG master core infrastructure by defining a new JTAG class and provide generic JTAG interfaces to allow the hardware-specific drivers to connect to this interface. So it's a bit of a mouthful, but I know you understand that. And this will enable all the JTAG drivers to use the common interfaces and have separate drivers for hardware implementations. So this work is ongoing. And by the way, the SBMG spec has not been published, but I want to come over here to give a preview and talk about it. So the roadmap ahead is that we want to work with the OCP community. We plan to contribute the SBBR document to OCP, like I mentioned earlier this morning. And then we plan to participate in several OCP work groups, including the security, the OSF, server, the hardware management. So these are all in plan. And then the OpenBMC, we will design these remote debug cases. And then we are also working on the PLDM reviews and distributions. OpenBMC, independent of ARM's effort, OpenBMC already are in the process of designing the software to support PLDM and MCTP. And we are participating to review. And then we also have DMTF participation as well. We're going to contribute to both Redfish and PMCI. PMCI is the work group that basically defines the PLDM and MCTP. And I recently actually hired a person who have been very active in that community to help. So I think we're going to strengthen that areas of participation. So call to action, basically it is for us to participate in OCP, not only ARM, but also ARM partners to be able to influence the hardware management spec and designs to make sure everything works with the ARM community as well. And then I also welcome everyone here to participate in the Server Advisory Committee to help define the the SBMG spec. It's not published. We still have some work to do, and we want your feedback. And you can send email to have the request. Right now, it's actually pretty simple. Like I said in the morning, it's just an NDA between Arm and the partner or whoever you are. But I think in the future, we are also looking for a way to maybe learn from OCP, right, and probably try to operate that committee more in the open, so anybody can join. And then, for Arm and Arm partners, we would want to encourage everyone to also participate in the Redfish, PMCI, and other DMTF working groups. Yeah, so that's what I have. Any questions?
Yeah, sure, I'll do the microphone. So you mentioned about, obviously, remote debug capabilities. This is working, yeah. You mentioned about remote debug capabilities, and unless I misinterpreted one of your previous slides, you were saying that then you would restrict access to who could have remote capabilities. So are they mutually exclusive, or is the plan to allow certain vendors to potentially access it remotely and other vendors not to?
No, I think the capability we want to design in the system, right? And what I was saying about the restricted access is more for the security concerns, right? So when you deploy the servers out there, then we need to look at maybe there needs to be a way to authenticate the user accesses, right? Because it's dangerous to open the the whole thing up, right? But I think the intent is to design in the capability for you to do the remote debug, but then also address the security side.
Long day. Any other questions? Let's thank our speaker.